All right, and so, does it look okay, sir? Cool. So when we have parallel, we're going to have what's called no intersections. And the way that we're looking at that is these are just representing arms, but they're representing two different lines right now. And throughout this topic, we're going to talk about graphing, a couple different methods, substitution, elimination, maybe even just drawing, but for now we're just going to focus on the graphs. So if they don't ever intersect, there's going to be 0 points. If they cross one time, and then your final one is going to be infinite. So we have none, 0, and infinite. So every time I ask you a question throughout this topic, the answer is going to be none, 1, or infinite. None, 1, or infinite. Okay, when would it be an infinite connection? When would we have infinite amount of intersections? Hey.
Undefined.
Some maybe. Two undefined. Could we have them not be undefined? Could there just be two regular slopes? What would they have to be?
Same slope and same line.
Yeah, same slope and same y-intercept. So if you have the exact same line, the lines are going to literally be on top of each other. So what we're going to do is we're going to use the graph to the right to determine whether these systems of equations have 0, 1, or infinite solutions, okay? So with that being said, my first two lines are already written in slope-intercept form. Y equals negative x minus 3 and y equals x minus 1. Y equals negative x minus 3 is going to be this line right here. Can everybody see that? And we're going to compare that with y equals x minus 1, which is this line right here. All right, let me ask you this. How many times do those two lines intersect? So that means that they only share one common point. They only intersect that one singular time. We're all okay there? All right, if I go to the next one, we're going to have 2x plus 2y equals negative 6. First of all, this is in standard form. We could not graph this at this time. What could we do to this equation that we would be able to graph it, Katie? Solve it, put it into slope-intercept form. Do we agree with that? So we're still using those same skills from earlier. Now, luckily for us, it's already graphed the lines, so we're not going to have to solve it out yet. The 2x plus 2y equals negative 6 is going to be this line right here. Same one we were just looking at, it's just in a different equation. And then we're going to have y equals negative x minus 3, which is going to be right here again. So let me ask you this. How many times are those lines going to intersect each other? Infinite, because they're on top of each other. It's the same line. Do you agree? All right, number 3. Y equals negative x minus 3. Okay, I'm going to erase it just so you can see it again. Y equals negative x minus 3. 2x plus 2y equals 4 is this one right here. What will we call those two lines? And so therefore, if they're parallel, are they ever going to intersect?
No.
Okay. Finally, the last one, 2x plus 2y equals negative 6, right here. And then we're going to have 3x plus y equals 3. All right, now, look at those. Maybe they don't cross yet, but they're getting very, very close to it. And therefore, if I were to extend these lines, so let's just continue what I'm doing here. How many times do they cross? One time, okay? Now, let's think back to our warm-up that we just did a few minutes ago. I took those two equations and I put them equal to each other. If I solve for those two equations, what do you think it's going to give me? It's going to give me an x value, which is going to be an ordered pair for this, and therefore by having that x value, we could solve for the y value to figure out where they actually cross each other. Okay? So that's all we're trying to do is just trying to figure out where do these lines cross each other? Where do they have a common ground? Okay, let's move on to the next part here. Okay, so sometimes, the majority of the time, we're going to actually have to graph these lines. It's going to give you the equation, we're going to graph it, and then we're going to compare it. How do you guys feel about graphing slope-intercept form? Pretty good, we've done it enough, it's not too bad. So if I take this first, and we have y equals negative 2x plus 1. I'm going to start at a positive 1, because that is my y-intercept. Is everybody okay with that? It's a negative line, which means it's going to be going down, because negative always goes down. So we're going to have 1, 2, 1, 1, 2, 1, 1, 2, 1. Is everybody okay with that line that I just graphed? Anybody have any questions how I did it? Okay, then we're going to have y equals 3x minus 1. So I'm going to start at negative 1, but this is a positive line. 1, 2, 3 over 1. Do I need to continue? Why? Somebody explain to me why I can be done with this problem. JT. They've already crossed. Remember, my three options are 1, 0, or what?
Infinite.
Infinite. Now, and y'all, if I just wanted to just convince to you that this is going to go on for, this is never going to cross again, well, y'all, aren't these lines going two separate directions? So they're never going to come back to each other. There's not just some magical number that they hit and then they bounce back. Right? This is it. You found your one intersecting point. All right, number 2. 2x minus 1. Y equals negative 2x minus 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Then we're going to have negative 2x plus 2. 1, 2, 1. 1, 2, 1. 2, 1. How many times are they going to intersect? 0, because they are. How could we have identified that without ever having to graph it? Steven.
They have the same slope with a different line.
Good. They have the same slope but a different y-intercept. So again, if you're remembering things from the previous units, you're able to save yourself some time from graphing. Do you understand? Obviously today, tomorrow, Wednesday, Thursday, we're going to be learning new skills. But guys, I've told you all year long, I don't care how you get the right answer. I just want you to get it. Does that make sense? Okay. What I'd like you to do is I would like you to try number 7 and 8. I'll scroll them up so you can see the actual equations. Just draw a quick graph, just sketch it. Doesn't have to be perfect. This is just your notes. What I would like for you to do is see on 7 and 8, 7 and 8, what they have. So again, we're looking for 0, infinite, or none. 1. 0, infinite, or 1. How about this? Let's just do number 7. Just number 7 right now. Don't worry about doing both of them. Just number 7. You tell me, is it 0, 1, or infinite? Just number 7 at the moment. I'll give everybody a couple more minutes to work on it. I know some of you already have the answer. Hang tight. Bennett, what do you think?
I don't know.
Brian, what do you think? 0? For number 7, you think 0? Carter, what do you think?
I think 1.
1? Let's check it out. So we're going to start at 0. Up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. Is everybody okay with how I drew that first line?
Yes.
Then we're going to have negative 1 as my y-intercept, but instead we're going to go down 2, 1, 2, 1, 2, 3, up 2, 1, 2, 1, 2, 3, one time. Okay, we all understanding how I did that. Try number 8 now. Try number 8. Again, I don't need you to draw a perfect graph. You guys see how I do mine up here sometimes? Just literally draw your line, give it a good estimate. You're looking for very simple things. 1, 0, or infinite. We'll get more technical at some point, but today it's just 1, 0, or infinite. Hey, what do you think?
1.
1? Hayden says, does anybody disagree? Let's check it out. We'll do 6. 1, 2, 3, 4, 5, 6. Agreed? 1?
Yep.
Alright, awesome.
Can you just say to have the same slope is either gonna be none or
Yes, sir.
infinite?
Yes, sir.
Okay, match different lines instead of
Yes, sir. Yes, sir. Any questions on what I've showed you so far? Anything that's confusing, not making sense, going too fast on? Alright, let's drop down to here. So now, we're kind of in that same realm where it's giving you the lines. But again, sometimes you're going to have to convert your equations from standard form to slope-intercept form. As you can see, it's already done it on the graph. I don't need to look at this graphic because we did this earlier, and I think we feel okay with that. What we will evolve to is not just telling me how many intersections, but figuring out what the actual ordered pairs that they cross at are. We're not there yet. Today, I just want you to understand 0, 1, or infinite. Now, if I scroll down to this last couple, notice that they're still in y equals. What I want to show you, though, is a couple different ways to identify easy decisions. Do these have the same slope?
No.
So at some point, they're going to have to cross then. Can we understand that? Do these have the same slope? So at some point, they're going to have to cross then. Do these have the same slope?
Yes.
Do they have the same y-intercept? So then what does that mean about them? They're parallel. So what I'm trying to show you, though, is if they don't have the same slope, at some point, whether it's early on, later on, they're going to cross. And when they cross, it's going to give me my one intersection. Understood? All right, so what I'm going to do is I'm going to go ahead and stop the recording. I'm going to pass your assignment out to you. We've got a good bit of time left, so what I want to do